Hello and welcome. This video will discuss about domain of a function. So before we go to the actual concept, let us see what is a function and what a function does. Function f of x, let's take function as f of x. We'll treat this function as a box. So what this box does is it accepts the input x and produces the output f of x according to a definite rule, according to some mathematical rule. For example, so if the function is defined as f of x is equal to x plus 3. So what the function essentially does here is it takes the input and adds 3 to it and produces the output. Let's say if x is equal to 1, then f of 1 is equal to 1 plus 3, which is 4. Similarly, if I take x is equal to minus 2, so f of minus 2 will be minus 2 plus 3, which is 1. So this is what a function does. It accepts the input and produces the output according to a rule. Let us consider one more example. Let us take one more example where, where, where f of x is equal to 1 over x. So here takes the input and puts it in the denominator, produces the output. Let's take some inputs. X is equal to 1. So what is f of 1? F of 1 is equal to 1 over 1, which is 1. So if you give x is equal to 2, so output is f of 2 is equal to 1 over 2, which is 1 by 2. Let us take one interesting input, x is equal to 0. So what is f of 0? F of 0. F of 0 is 1 over 0, which is undefined. So from this, we understand that some inputs will not produce defined outputs, finite outputs. So, so this gets us to the essence of what the domain is. So in this example, you can take any value of x in the real numbers, any value in the real numbers. It will produce defined outputs. But for x is equal to 0, this function f of x, which is 1 by x, fails to produce a defined output. So the the inputs which produces the inputs which produces defined outputs or finite outputs, defined or finite outputs, or we can say all the inputs, or or set of inputs which produces defined or finite outputs is called the domain of a function. It's called the domain of the function, or the set of inputs which has defined outputs is called the domain of the function. So for this example, domain we can write as x. X can take any value in the real number except x is equal to except x is equal to 0, and we can put it as inside the set. Any number you take will produce a finite output, but for 0 it will fail to produce the output. So 0 will not come inside the domain. There are many other ways to represent the domain. You can write like this: minus, so this is a real number except 0, right? Like this. Or we can write minus infinity to plus infinity, any number except 0. These are the many ways to represent a domain. Let us consider one more example to make it concrete. Let's say we have g of x is equal to square root of x minus 3. Let us find the domain of this function. Right? x minus 3. So we know that when we write square root, any number which is under this root, this should be a positive value. This should be a positive value in order for us to get the finite value, finite or defined value, finite or defined value. So what makes this number positive? So this the condition is x minus 3 should be greater than or equal to 0, because we know that square root of negative numbers, the square root of 5 minus 5, we don't get a real value. This does not belong to the real number. So the number under the root should be a positive number. So what makes this positive? So this complete thing should be positive. So x should be any value greater than or equal to 3 produces a positive number, which produces the output a finite value. So for example, if I take x is equal to 4, if I take x is equal to 4, square root of 4 minus 3 is square root of 1. So this is actually a finite number, or it does belong to a real number. If I take x less than 3, let's say if I do x is equal to 2, I'll get 2 minus 3, which is square root of minus 1. So this does not belong to real number. So 2 will not come to the domain of this function g of x. So the domain of this function is actually any value x greater than or equal to 3. So or we can represent this as x would take any number, the real number, such that x is greater than or equal to 3, or we can write this as also as 3 is included, and infinity. Up 3 to infinity, it gives the positive value. That positive value will have a finite square root value. So essentially, what domain is if I have a function which accepts the input and produces the output f of x. So this input will have some number, some sets, which produces the output, which are finite, and such numbers which comes inside this is called the domain. So any number, let's say if I have a number here, if you give the number to this function will be able to produce a finite output. Any number which is outside the domain, if you give this, the function will say, no, I don't have a finite value or a defined value for this. So this will not come in under the domain. For example, let us take one more example. F of x is equal to 1 by square root of x minus 2. So here the condition is any number this any number under the root should be a positive value. But one condition here is, if I take x is equal to 2, what happens? If I take x is equal to 2, I'll get square root of 2 minus 2, which is 1 by square root of 0, and 1 by 0 is not defined. So domain of this function is domain is this function is actually x minus 2 greater than 2. So sorry, x minus 2 greater than 0 0. So x is greater than 2. So there is a difference between this problem and the previous one. If the square root is so if the square root of anything is comes in the numerator like this, then x is equal to 2 is also included. But when it comes to denominator, x is equal to 2 is not included. So the domain of this function is actually x greater than 2, or x belongs to R, such that x is greater than 2. Or also we can write the domain is 2 is not included here. So domain is 2 comma infinity. So this is all about domain. In the next video we shall discuss about the range. Thank you.